Okay, we're back on this Samsung 3-wire. I'm just gonna answer some of the questions in this video. So the first thing is, one of you was talking about the if it blows the thermal fuse, you should change the cycling thermostat. I'm pretty sure. Now this was a while ago, so I can't. But I'm pretty sure I changed the cycling thermostat and the thermal fuse when I originally changed the heat element. So what we're gonna do today though is we're gonna watch it run. Okay, the second thing that somebody said was, or that they wanted, was to know what the ohms are on a 3-wire. So basically what is happening here, and I'm gonna try to film this if I can, but is there's two heaters. And then, so the middle wire is a common, and then, yeah, there's two heaters, and I'm not sure when it turns which one on, or whatever, right? Like, so the bottom wire and the middle wire says 13.8 on the 200 range. So if I move it up to the 2000 range, it says 40. If I move it up to the 20,000 range, it's 0.02. Okay, let's do the middle wire and the top wire. Okay, on 200 range, we're showing 32. Showing about 30 on the 200 range for the top and the middle wire. Now this is the OEM element. So on the 2000 range, it's like not working for some reason. So maybe it's too low. I'm not exactly sure how to read or what that means. So hopefully that helps with that. Okay, so the other thing, somebody said the circuit board is bad. Okay, so let's check out the circuit board. So what they said, basically I had a circuit board that, I've had this happen where the relay on the circuit board gets stuck closed, and so the heater's always on, which would obviously blow the thermal fuse. However, there's a cycling thermostat, so you know, like what was happening there is I would turn the dryer off, just plugging the dryer in, turn the heat element on. So that could happen, you know, it has happened. Okay, so what we're gonna do here, we're gonna get to the board. I'm gonna take out this screw. Obviously this machine's unplugged. Don't do this. And if you're gonna do this, definitely don't plug the machine in while you do this. Okay, so now I'm just gonna like lift it up like that, and we're gonna find this board here. So here's the UI board. The board that we're looking for is in here, which has a some relays on it. Okay, so what they're talking about, let's just take this UI board off here. And this one, there we go. So now I should be able to kind of pull this out like that, flip it over. Okay, so here we have two relays. One of these is going to be for the motor, and the other one is going to be for the heater. Now, oh, there's 3 relays on this board. It might be there's 3 because there's 3 coils, right? Or there's 2 coils. But I'm not sure which is which. Like, you would think that this would be the heater relay because it's thicker wire. And we have a blue. And I think I saw this on another Samsung board I was working on the other day. So I think this is the motor relay. I think this is the big heater relay. And this might be the small heater relay. I don't know. But let's just test all of them. Okay, because I think what they're thinking is that the circuit board, and I could be bad, or I could be wrong. If you commented this and you were thinking something else, then comment, I guess, again. And sorry for misunderstanding, but I might try to put the comments around somewhere on the video. So, okay, where's my meter? Okay, so let's do continuity. And I think the idea here is that if I meter this relay and it shows continuity right now when it shouldn't, then it would be bad, right? So that one has no continuity. So the idea here is that the relay is welded shut and it's just blowing thermal fuses because it's welded shut. Well, there's no continuity there either. So I've had this happen before. It's a possible thing, right? And there's no continuity there either. Now the reason why I already knew this was gonna not be the thing, because I watched this thing cycle, okay, at the customer's house. The first time it blew the thermal fuse at their house, I turned it on without the front on it and I watched it cycle. Okay, so like, yes, I understand that it could just be the cycling thermostat that's making it cycle, but it is cycling nonetheless. So shouldn't really be blowing the thermal fuse if it's cycling. Right now the problem here is the dryer that I was working on the other day has a stuck relay, because when I plug it in, or at least I thought it did, when I plugged in the other dryer, the motor always turns. So the motor is somehow getting power to it all the time. Now I don't know if there's something wrong inside the motor on the other dryer, or because I took the board apart and I tested the relays and none of them showed continuity. So I don't know what's going on with that one, but this is how I had tested before. Now the question is this getting power from the board? Because I can't test the other side of these relays. I can only test this side. So I'm assuming that it's connecting this to this when the relay triggers. This to this when the relay triggers. This to this when the relay triggers. Which I could plug it in and turn it on and see. But I don't think it's the board. But somebody thought it might be the board. Okay, so we did those two tests. So that we tested the relays on the board. I showed you the ohms of what the OEM element is supposed to be. So here is the Amazon element. Now this is still good. Oh, the other thing is somebody said was that the crimp failed, and I think he's right. You know, so these two were crimped onto another wire, right? So he said that the crimp failed and that's why this one came off. I think he's right, but what we're gonna do here, let's just ohm out. So we're gonna measure the resistance of the small wire element. So let's see what we get here. The small wire element on 200 on this one, which I don't know if that's the top or the bottom. It looks like it's 35. It's kind of going all over the place. Okay, the big wire element on the Amazon version on 200 is 14. Okay, so there's the ohms of the Amazon element. So let's plug this in here. Let's plug this UI board back in, and then we will watch the thing run. I don't know, I'll probably listen for these relays, see what the dealio is. So does the board just turn the relay on and rely on the cycling thermostat? Is that the way that it works, I wonder? I think that's what it is. So it's usually what it is, but the thing is like if we turn on low heat It doesn't make sense. It doesn't make sense why it would blow the yeah, I don't know. Okay, I'm gonna move this over here. Okay, so if we want it on low, so let's go to time dry here. Low. We'll start.
So I don't know if you can see that, but the bottom element is on only. Now the thermostat, this thermostat is only near the bottom, right? The thermostat is not near the top coil, and the top coil is the small coil. So if we put the big coil on the top, like the Amazon one, then would it function correctly?
So the bottom coil's on right now, the big one. Let me grab my thermometer here. Okay. We look back in there. That's at 280.
And I just heard a click down here. So now the bottom coil is off. So obviously it's cycling. And so that's on low heat, right? So, and I don't know if that was the high temperature or the high thermostat cycle or the low temp cycle. Thermostat cycling. I don't know which one clicked, but okay, we clicked again there. 500 degrees in there. The bottom coil is on again. Just clicked off again. So that's how fast we're cycling here.
Turn the dryer off here, so it's still plugged in.
Okay, there's no heat element on. The heat element is all the way off. So now
let's go turn it on. Let's go to time dry, and we'll go to high. Okay, it just automatically went to high. Let's turn off eco dry, turn it to high, and push start. Okay, it just turned on.
Only using the bottom coil. So what's the point of the top coil?
Okay, let's try eco dry now. Eco dry, normal. It's gonna make me do medium heat.
Okay, so now only the top element is is on. So, and I think they were running in Eco Dry, which would mean if it only turned the top element on Eco Dry and it was the wrong element, it was the hotter element and it's trying to run the cooler element, and the cycling thermostat for the hotter element is on the bottom, wouldn't that mean that it would blow the limit switch, which is in the middle of them? You know what I mean? This is exactly what I considered it was doing, is if it's turning on the hot heater when it thinks it's turning on the colder heater, then it's running hotter than it should, because the cycling thermostat is very far away. You know what I mean? Like, I don't know if I can get my laser pointer. Right now the top heater is on, okay? It's on eco mode, the top heater's on, and the cycling thermostat's down here on the bottom. It's right there where that green light is. The heater is up here. There's that plate in the middle that would block the heat. So if the hot heater is on top, it's not going to cycle the thermostat correctly. It's going to heat up too much and blow the fuse. So I didn't hear a click, and the top element just turned off. So does that mean that the top element is controlled by the circuit board, not by cycling thermostat? Is the top element timed?
Oh, it turned off because it's on sensor dry. So see, turned it off. So let's try to get it on eco dry and time dry here. I think that might be the answer though. Let's do time dry, eco dry. It was on medium heat. Let's try that. Time dry, so it doesn't, we know it's not going to turn it off, and then eco dry here. Push start. So I wonder if eco dry just runs that top element.
No, now the bottom element's on. The thing, looks like they might both be on, and it might just be the bottom, but the bottom's definitely on.
So the thing is they weren't running in time dry. They were running in eco dry and sensor dry. And when I had it in eco and sensor, it only turned the top element on.
So instead of it, so like right now, it's gonna run the cycling thermostat. See, it just clicked.
So would the thicker wire be the hotter element? So what is happening is on eco dry and sensor dry, it runs the top element. Okay, now the thermostat, let me show you guys. The operating thermostat sits right here. So it's got like this metal plate that kind of blocks the heat from here to this, right? So, you know, it may not be set up correctly to be in this orientation, because what has happened, this is what's happening. We put it on sensor dry and eco dry, it runs this element, and there is no cycling thermostat here. So maybe it has a bad cycling thermostat on the output, and it relies on that thermostat for the top heater. I don't know. I don't know, but you know, I'm just going to continue to test, and I'm going to overuse this machine before I try to sell it to anybody again. But let me know what you guys think. So my theory is still this. Okay, here's my theory. Is still that this big element on the top got too hot and blew the fuse. And so on certain modes, it's only running this element, but it thinks it's running the cooler element, 1500 watt element, which might run cooler to where it's not going to blow the thermal fuse. But since it's upside down, it's running the hot element when it thinks it's running the cold element, and it blows the thermal fuse. That's my theory. I don't know. I have no idea of knowing what is what, but you know, that's my theory for now. So I'm moving this video ahead in line because so many people were interested in it, and after all, I'm really just doing this channel to help anybody that I could help, and to show my customers what I'm doing to their machines. So that's why I started this channel, or the last version of it, I should say. But anyways, let me know what you guys think. So but yeah, good luck with your 3-wires. I don't know, you know, in the past when machines come back, I often take them to the scrapyard. So I'm not sure this machine will get sold again. It's too bad because it's in good condition, and you know, it works good. As long as it doesn't do this, then it'd be fine. So I don't know, we'll see. I'll test it a bunch and see. But yeah, thanks for watching. Thanks for commenting, and let me know what you guys think. You guys are helping me out a lot too, so I'm learning a lot from the comments, which is, you know, important. Especially in this situation where all these dryers, they're all so different and stuff. It's like, you know, yeah, well, you know. Anyways, okay, thanks, bye.